This is Spencer Riggs with Design Department, and this is a first episode of our new series, An Engineered Approach, where we take existing products or devices and do a critical breakdown to address room for improvement and how we do it. Now, our goal isn't to provide comprehensive solutions to complex problems, but to have a conversation around thought-provoking ideas. For more compelling content, check out our page for our other series, Greatest Engineering Triumphs and Blunders. So today we're talking about transportation in America. Specifically, we're going to be talking about economical individual transportation. The reason we're taking this approach is because public transport is more of an infrastructure question, and the reality is that outside of major metropolitan areas, the viability drops off significantly. So the auto industry is an ever-evolving environment and one that's become increasingly hard to navigate over the last few years. More features, manpower, materials, and money are being spent now than ever before to create a product that is desirable and offers higher and higher levels of performance within its market sector. But does all of this really meet the demands of the market? Where does this leave the market segment looking for affordable transportation? So the infrastructure for mass adoption of EV technology simply isn't there yet. And this leaves us with an interesting predicament. Certain states have put into motion regulations that mean that ICE cars, internal combustion cars, will no longer be allowed to be sold by 2030. And the economic implications of this is that those seeking to buy a new car now are faced with a troubling reality. They can either pay twice as much to have something that, with current battery technology and charging options, means their investment will be net zero at best, depending on the area, or they can buy an ICE car that will have an unnatural level of depreciation as regulations force those internal combustion vehicles out of the market. So to summarize this, cars are more expensive with a shorter economic lifespan and in many cases mechanical lifespan than in previous years. And EVs, while they could be a solution, aren't a great one yet for everyone. So what can we do about this? How can we flip a potential lose-lose situation to a categorical win? As a country, we need a transitionary vehicle, one cheap enough to be accessible to everyone, feature-dense enough to be competitive, and fuel economical enough to meet increasing demands of the EPA. So factoring in the elements we have to work with, we can start to look at the quotey fingers prior art or predicate design. The fiscal, mechanical, and regulatory restrictions, while not exact, do mimic the Japanese domestic auto market surprisingly closely. And their regulations on displacement, taxation, weight, and fuel efficiency have created a demand for decades. And their answer to this demand? The K car, spelled K-E-I. Now, the K car auto segment composes a series of, by American standards, ultralight compact automobiles designed for city use. As of 1990, they are restricted to only 660 cc's of displacement regardless of body style. They do, however, have an answer for every market from trucks to sports cars to SUVs within that range. And the sector is also fairly consistent on price, roughly $7,000 to $13,000 US dollars equivalent brand new today. Now, by comparison, the average car cost in 2023 for a new vehicle in America is about $48,000, with the cheapest of our new range starting at $19,000 for a four-door sedan, $21,500 for an SUV, $25,000 for a truck, and $33,000 for a sport coupe. Now, those options are all absolute bottom-end base models from our local area around the DDI office here in Milwaukee. And it's important to recognize some key factors that make the K car a success overseas beyond the monetary if we want to come up with a concept that is competitive. And level of urbanization is a huge factor since these designs are traditionally made for cities. And given that 91.7% of Japanese live in urban areas, this makes sense. And that was just a quick Google search. The US, by contrast, sits at about 83%, according to a study by the University of Michigan. And finally, the Japanese have an average family of 2.25 people per household as of 2021, compared to America's 3.13. In America, we have more people fitting in cars and we're farther apart with higher average speeds. And that's relevant because the top speeds of these K cars are about 87 miles per hour for the newer models, with some as low as 60. And that said, we can assume that 660 cc's just isn't enough when considering the average load is more substantial by, I would say, about 200 pounds, factoring people alone. And that, combined with the extended distances presented by Continental Living, would have ruinous effects on longevity. So double it. That's what Chevy did for the Trax and Mitsubishi did for the Mirage. Problem solved. They already make a solution, but not quite. These are, in practicality, American K cars, relatively affordable, compact, small engines, enough screens to keep the average American feeling like it meets the standard of living. The problem is they only appeal to one market segment, and the way these cars are manufactured is also not conducive to profitability. And many brands have attempted and lost money producing economy cars like their flagship models. However, modern electronics and infotainment systems can be added to these economy vehicles, which add a ton of customer value and can help bridge the gap between basic transportation and an economy car, while still providing a wonderful driving experience. In order to solve the problem of transportation, we need a different outlook and a different way of making things. We understand and have framed the problem, but how do we get to a solution? Prior to the 90s, many standards were adopted across vehicle lines and manufacturers. Those standard headlights, switches, fuses made things cheaper and easier to produce because individual companies weren't shouldering the full load of development and production per individual vehicle. These standards stood over multiple generations of vehicles as well. And so taking this approach of standardization combined with a kind of open source could really turn the tide. Now, imagine a modular chassis small enough to be used for a passenger car, robust enough to be used as an ultralight truck. Imagine a 1.2 to 1.6 liter line of highly efficient internal combustion engines, robust enough to meet the same demands. And imagine using standardized components and commonly sourceable electronics to minimize overhead. Imagine an American K car that has been optimized to be more than just cheap, but play an integral part of our day-to-day lives. This is Spencer Riggs with an engineered approach to solving the problem of American transportation. I would love to hear your thoughts and comments below.